Hi, it's Mr. Bennett here. We're going to go through some motion graphs today. The sort of questions you might get in a test or an assignment. So we'll look at this first example. So what we've got here is a motorbike that's moving on a straight stretch of road as a function of time. The motorcyclist starts 200 metres north of the intersection. Alright, so you're obviously seeing what's actually happening here, describing. So we're moving away from the intersection. Then we're probably stationary there, moving back towards the intersection, go through the intersection. We go through 200 metres, and then we stop and we turn around and we go back to the intersection. Do you get the idea of the motion there? So during what time interval is a motorcyclist travelling in a northerly direction? So that's going upwards. So that would be, if we're looking at our time periods. Now, you're going to have to use some math skills here. In terms of the way you present the information. So I might work in blue if that's alright. So obviously from 0 through to this time period, which is 20 seconds. So from 0, so t greater than 0 and less than 20 seconds, it's moving in northerly direction. And then from this point here, so that's 55 through to 70 seconds. So it's there. And 55 and t is greater than that, but it's less than 70 seconds. Right, so that's when it's actually moving in a northerly direction. So obviously when it's not moving in a northerly direction, it's probably moving in the southerly direction, unless it's stationary. So here is the point where it's actually moving in a southerly direction. So that's from 45 seconds through to 55 seconds. So 45 t and then it's less than 55 seconds. Obviously at 55 seconds it's going to be stationary because it's changing direction, isn't it? So you've got to be stationary for a period of time. So when is the object stationary? Well, stationary from 20 seconds through to 45 seconds and then at 55 seconds. So stationary from 20 seconds through to 45 seconds, and when t is equal to 55 seconds. So when does the motorcyclist travel back through the intersection? Well, travels back through the intersection at this time here, which would be, it's 55, about 52 seconds. And then at 70 seconds. Right, so we just put those things. So you're just using the graph to read off the information. Right, and t is equal to and 70 seconds. Right, calculate the instantaneous velocity at t equals 15 seconds. Now, along this line here, the velocity is going to be the same. It's constant because it's a straight line graph. So remember what velocity is. The velocity is the change in the distance over the time, or displacement over the time. So it's going from 200 up to 3, 4, 5, 600. So it's going 400 metres in 20 seconds. Okay, so the velocity along that line is going to be the same at any particular time. So it's going up 400 over 20 seconds. So that means it's actually moving at 20 meters per second, and then we should give a direction, so that's northerly, north. You've got to give a direction because it's a vector quantity, don't you? Right, for the 70, so it should be 70 seconds, okay, of motion. Calculate the average velocity of the motorcyclist. So remember, velocity is the displacement over the time. So in fact, it's gone from 200 metres back to 0. Alright, so technically it's actually gone minus 200 metres, hasn't it? So it's moved backwards 200 metres. So therefore our velocity is going to be minus 200 metres all over 70 seconds. Cross the 0 off. So it's just going to be just under 3. I'll work my calculator there. See if that works. Takes a while to come up. Well, you can read that out anyway, it doesn't really matter. So it's just going to be just under 3. The average velocity of the motorcyclist is going to be the distance travelled. Now, if we count the distance travelled, it goes, for section number 1, it goes 400 metres away from the intersection. It's not really moving anywhere there. Then it travels another 600 metres back, so that's now a kilometre it's travelled, isn't it? And then it goes another 200, so that's 1200, and then it goes back another 200, so that's 1400. So it's travelling 1400 metres, so our speed is equal to 1400 all over 70. So that's going to work out to be 20 metres per second. Alright, so that's roughly approximately equal to just under 3 metres per second, and that's going to be minus because it's moving in the negative direction. Alright, so they're the sort of questions that you'll get to do with a position versus time graph. Now, the other type of graph that you'll see when we do these questions is going to be a velocity versus time graph. Now, a velocity versus time graph basically is the one that you'll use when you want to work out the distance travelled and so on. Alright, so let's have a look at this one here, the example. What's the example of? And we've got to put these in context. I think it's a hot air balloon or something like that, a balloon going up in the air. Alright, so, calculators come up. Now, so if we're doing this question here, we'll work in blue again. So with this question here, what is the velocity of the balloon at t equals 2 seconds and 11 seconds? Well, you just read it off the graph. So at 2 seconds, you'd say it's 5, 10, 15, 20, 25. It's probably about 27 seconds. So that one there is about 27 metres per second. 11 seconds, okay, which is there, works out to be 20 metres per second. So you're just reading it off the graph at those 2 points. Calculate the acceleration. Now, the acceleration of that is a change in velocity over the time. So for this first segment, we're going from 0 through to 40 metres per second. Okay, so the change in velocity is in fact positive 40. So for number 1, our acceleration is, so our final velocity is 40, take in 0, I've got a time period of 3 seconds, isn't it? So therefore, that's going to be 40 on 3, which is about 13 1/3, isn't it? So 13.3 metres per second squared. So that's number 1. From 3 to 8, so from this section here, from 3 through to 8, it's not changing its velocity. Its velocity is staying constant at 40 metres per second. So for that segment in there, for number 2, we know that the acceleration is equal to 0 metres per second. And then for part 3, we're looking from 8 to 14. Now, it's going from, for part 3, the acceleration is the change in velocity. So the final velocity is going to be 0, the initial velocity is 40, and that's over a time period of 6 seconds. So therefore, 6 on there, it's going to be roughly 6 and, 4, so 2/3. So it's going to be something like minus 6.66 metres per second squared. Alright, now, so that's working out the acceleration change in velocity over time. Find the displacement of the balloon over the 14 seconds. So the displacement is in fact the distance it's travelled from the start to the finish. Right, so if we think about closing our eyes, okay, if we close our eyes, it's at 0 when we start, we've been away for 14 seconds, we open our eyes and we're at 0 again. So technically the displacement for this particular case here is 0. So our displacement is in fact 0 metres. Alright? actually that's not true. So when we start talking about the displacement, what we need to talk about is we need to talk about the distance travelled of the balloon over this period of time. So the displacement is going to be the area under the curve. All right. So what we have to do is have to break this into shapes. All right. So we've got a triangle there, we've got a rectangle there, and then we've got another triangle there. So if we're thinking about a displacement, so our S is going to be equal to a triangle. Our first triangle has got a height of 40. It's got a distance of 3 plus a rectangle. Our rectangle is going to have, I think that goes from 3 to 8, so that's 5. So that's 5 by 40. And then our other triangle over here is going to be 40 by 6. So therefore that's going to be equal to a half of 3 by 40 plus 5 times by 40 plus a half of 6 by 40. Right, so if we work that out, that's going to be equal to 120/60 plus 200 plus this one over here, 240, that's going to be 120. So when we add those together, 320, 380, it's going to travel 380 metres in that particular time period. Now, if we want to sketch a velocity acceleration versus time graph, what you'll find, these sort of graphs here are going to be step graphs. So if I just draw my axes here, a little bit dodgy, time, acceleration, right? So acceleration is measured in metres per second squared. It's a little 2, and that's times measured in seconds. So for our first segment, it's going a positive velocity, it's moving upwards, isn't it? Okay, and it's got a velocity of, in that segment there, I think we worked it out to be, well, it's got an acceleration in that first segment of 13.3. The next segment's got an acceleration of 0, and the next segment's got an acceleration of minus 6.66. So our acceleration versus time graph is going to be a first bit there for the first 3 seconds. So that's 3, and that's going to be 13.33. Then it's going to be stationary over here until the 8 second mark. And then it's going to come down over here and to the 14 second mark. It's going to have a slope, a value of minus 6.6. Alright, so it's a sort of step function that you look at when you start looking at the acceleration. Right, now it doesn't always have to be. Now obviously if this particular line here curved, then that won't be constant acceleration. The acceleration may be changing, right, at a different rate. Alright, so there are two fairly common examples when we start looking at velocity and acceleration. Now, I know in your tutorials that you've got for this topic, there are a range of these questions to work through. And again, we'll be working through those in class. Really what you have to do, as I've mentioned before in physics, you have to try and understand the concept behind this rather than trying to memorise, what to do. So it's really about you working through some of those activities in your textbook, but also being able to think about, if I was walking, this out, what sort of motion would I be doing? All right, so anyway, we'll work in that in class. Good luck with this. Have a go at some of those questions out of the tutorial, and I'll talk to you. But make sure you catch up with me if you need some help.